First of all, most of people haven't heard of this term combinatorics. If you look a bit deeper, you will recognize that the root of that word is combine or combination. So from this alone, you can deduce that this realm of mathematics has to do with understanding combinations. So now that you understood the word, the question is, what's the use of this subject? Let's say that you have in total 5 pants and 5 shirts. Each of the 10 clothes that you have are of different colors. Aren't you curious to know how many days can you be spotted by your friends unique you wearing a unique dress just by using those 10 different items? Well, in order to find that number, you will need combinatorics. The answer is quite simple in this case. You have to multiply 5 pants with 5 shirts. In this way, there is a total possibility for you to have 25 days in which you will be wearing clothes that you were not wearing any day earlier. You can easily imagine then that this kind of mathematics will be very useful in making decisions about how to arrange a room for a conference or the various possible combinations of games in a tournament. Also, it can help you in analyzing the different possible outcomes of any decisions that you have to be taking. Finally, this topic will help you in calculating probabilities. For example, when you place a bet, don't you want to know what is the probability of you winning? Well, combinatorics provide you the number that will help you make that decision on whether to bet or not. For example, you are given a choice between playing a game with 2 dices or 3 dices. Your bet is that you will get a sum of 6. Using how many dices will your probability to win increase? I will not take you into the calculation, but the answer is you have 3 times more chances of winning the bet if you choose to play with 2 dice instead of 3 dices. So these are just some practical uses of probability and combinatorics as a whole. As the name implies, trigonometry has got to do with triangles. It's essential that you know this component of mathematics if you want to be a surveyor or an engineer or an architect, and even if you enter computer graphics. But even if you do not become any of these, trigonometry can still be used to determine the height of a tower without actually using a measuring tape. Can help you design slopes. If you have the hobby of watching the stars, then it can help you determine distances between stars. You must remember that even the pyramids of Giza in Egypt were built using trigonometry. So finally, we reach calculus. It's the most hated component of mathematics among students because the notations appear so advanced and scientific or presumptuous, you can say. And that is why we are deterred by calculus, which is actually very simple if you are motivated enough to learn about it. As we will discuss in the next section, the rules are not that complicated. So if you are able to do algebra, calculus isn't more difficult or complex in terms of procedures. Yes, it's only the concept that is difficult to grasp many times. But sticking to the objective in this section, by mastering calculus, you can be assured to have a great career in engineering, data science, research, finance, and anything that has to do with making predictions. You must understand that most of the modern technologies that we are used to now were designed either using calculus or are using calculus to serve their purposes. In order to send the rocket to space or to the moon, you need to know how fast it is going and how much fuel it has consumed at any point. Without this information, mission control wouldn't able to fly the rocket and bring it back. And obviously, such answers are provided by calculus. You need to have calculus in order to run factories even. It is required to find the optimal level of stock or optimal production level or even the break-even point in economics. Without calculus, it's very difficult to do extremely large and complex operations. At one point, guesswork and estimation do not work. This is where calculus comes in. A quick example of mental calculus, although you don't know it is calculus that you are doing, is when you are crossing the road. Your mind is making an equation based on the speed of the cars coming towards you, the timer in the green light, the obstructions that might be in the road, and the time it is required for you to cross the road. Then you also factor in your own speed of crossing the road. In this way, you have some kind of equation in your mind. Then you differentiate that equation in order to find the rate at which the cars are moving. It might be uniform or it might be non-uniform. Then you come to find the maximum possible speed and location on the road that the cars might find themselves in. If you think that their rate of velocity is manageable and the maximum speed is within your comfort zone, then you will make your run and cross the road. In this way, knowingly or unknowingly, you did some mental calculus. I'm sure that many mathematicians who are reading this section will raise their eyebrows. But again, the objective of this whole section was not to be mathematically correct, but to generate interest in the students and make them less threatened about mathematics. As I've been telling you earlier, I'm no mathematician and I'm certainly not a mathematics teacher. I just love maths, but not the way academicians are presenting it. This is why I am writing this chapter anyways. Finally, under calculus, many people wonder what is the use of antiderivatives. Well, it's basically to calculate areas. If you have to calculate the area of a square, geometry has given you the answer. Calculate the square of the length, the square, and you'll get the area. The area of the triangle is also given as half of the sum of the base and perpendicular. The area of the circle is pi r square. But what if the shape that you want to find the area of looks like a wave or has a very odd shape? How would you calculate the area? Well, first you need to find the nearest equation that describes that equation. For example, it would be y is equal to x squared if it looks like a parabola. Next, all you need to do is make the integration and you'll find the area. And that's the power of calculus. So I hope that this section was very useful for you and it lowered your guards against this threatening perception of mathematics. My objective was to make you feel lighter about this subject. I don't expect to be factually correct or even academically correct in this section or even in this chapter. I just remind you that my objective is to develop love of mathematics. It's not a monster or a wild bear. It's an angel and a teddy bear.